What is a formation, and how do formations differ from members and groups? A formation is the basic unit of geological mapping. Every sedimentary and metasedimentary rock has to be grouped into a formation. Formations are defined on lithology, and they must be mappable units. Formations are not defined on their chemistry or their age or their fossil content. They're defined on their lithology. When you characterize a formation, you have to describe the lower and upper contacts, the lithology, and the lateral extent. If we look at the 1 in a million map of South Africa, we can see formations that are mapped, such as the Multino, the Elliott, and the Clarence formations. The International Commission on Stratigraphy, or ICN, provides guidelines on how to name formations. The rules are quite specific, and every stratigrapher has to follow them. Formations have to be named after places. This is to ensure the longevity of the names. Every student of geology is tempted to give formations silly names. The Cowpat Formation, or the I Fell in the River Formation. But they must be named after persistent geographic features. Think of the formations you know. For example, the Multino Formation, named after a town in the Eastern Cape, or the Orange Grove Formation, named for a suburb in Joburg. Each formation is named for a geographic feature. This ensures that future stratigraphers know where to find good exposures of the formation, and also to ensure that the name has longevity. Your job as a mapping geologist is to define and map formations. Very thin units wouldn't make good formations because they wouldn't appear on a geological map. Equally, very thick units might have multiple lithologies in them and therefore be better defined into multiple formations. In an example in the Cape supergroup, alternating layers of sandstone and shale can be divided into different formations. What about members, beds, groups, and supergroups? Members and beds are smaller than formations. And so within a formation, you could have a particularly characteristic unit that helps with correlation, and that would be called a member. But a member would be too small to be mappable. The smallest stratigraphic units are called beds. Beds are particularly distinctive layers that are not useful for correlation, but they are marked and may help position you within a formation. You'll notice that although every rock has to be divided up into formations, not every rock needs to be grouped into a member or bed. There can be parts of a formation that are uncharacterized and other parts of a formation that are divided into members. Beds are smaller than members, and they represent distinctive layers. For example, the contorted bed in the Parktown Formation. In volcanic units, instead of beds, we refer to flows, and flows mark single eruptive events. Larger than formations, we have groups and supergroups. The Beaufort group consists of 7 different formations, and they're all genetically linked. They're all fluvial. At an even larger scale, the Karoo supergroup represents over 100 million years of crustal evolution and subsidence, and has multiple different depositional environments, from glacial deposits at the bottom to Aeolian deposits at the top. For plutonic igneous rocks, we don't use formations and groups. Where plutons are simple and they only have 1 or 2 lithologies, we would use the term suite. For example, the Cape Granite Suite. And where plutons are more complicated and they have multiple lithologies as well as structural features, then we would use the term complex. For example, the Bushveld Igneous Complex. South Africa has an excellent stratigraphic framework thanks to the existence of the South African Committee for Stratigraphy. or SACs. SACs publishes definitions for each formation, and in these definitions you'd find the locations, the lithologies, the contact types, the fossil content of any particular formation. This allows researchers to know exactly how a formation is defined. The location is especially important. Each formation has a type section, and the type section is easily accessible, so anyone can go to the type section and see the formation at its finest. Every stratigraphic unit must be systematically described. This ensures that future researchers know exactly what was meant by the person who originally proposed the name. This allows everyone to use the same words consistently, and it's essential to everyone who uses geological maps. And this concludes the video on lithostratigraphic mapping.